Okay, number 10 here is giving you 4 functions and it graphed them all for you. Check those out on your calculator. Okay, time-wise, it would be crazy if I did that now. But then letter B says, consider the function m of x equals e to the x. Don't worry about using your knowledge. Literally put in y equals e to the x in your calculator. Okay, and go to your table, second graph. You'll notice it hits at 0, 1, just like these did. Then at 1, it's 2.71. Well, that's e, isn't it? And think of it, what's e to the first? E. And e is a number, 2.71, 828. So if you go over to 1, and 2.71828 is about here. So it follows kind of close to that other one. Then it goes up to 7.38. So at 2, it goes way off the graph up here. Okay. Negative 1, it's at 0.36, which is about here. This graph does get a little crazy. So the actual E graph, let's try that again. There we go. There's your m of x. And yeah, it might have some overlapping points with the others, but they designed it to do that. Okay, so that's what e to the x looks like. No big deal. Just like I said, put it in your calculator, look at your table. Now, as I was saying, this is PERT or NERT. Continuous compounding, continuously. Okay, the initial, the rate, the time, and how many in terms of population. Say n of t, or it might even say for an account, my goodness, it might say p of t. Okay, so it just depends on what you're given. So let's take a look at a population problem. These are kind of cool. I've always liked these because it always shows you what's going on and how you can actually figure out population. It's something that honestly you could take a career in very easily. How do you think they're going to do the census? So if we look at this problem, it says the population of the city of Fredericksburg, Virginia was approximately 19,360 in the year 2000. And has been continuously growing at a rate of 2.9%. All right, 2.9 we know is 0.29, again, divided by 100. Continuously, there's our PERT formula. So use the formula for population growth to write a function to model this growth. Okay, well, simple as what we're dealing with. We'll use P of t this time. We'll use our PERT. So 19,360 E. The rate is 0.029 T. See, I think the continuous ones are almost easier. All you're using is a straightforward PERT every time. So then it says, use your function model to predict the population in 2020. So obviously, let me double check what they're doing here first so I don't give you their wrong answer. We would have 19,360. Second ln to give me my e, 0.029. And now think about it. How many years is it from 2000 to 2020? Obviously here, t is going to be 20 years. And they round it. So I guess the book decides that you're also allowed to round people, parts of people. That's fabulous. It's wrong. Okay? The actual answer here would be, again, P of t equals 19,360 e to the 0.029 times 20. you end up with a new population of 34,577. We don't round that. You can't. You can't round a person. God, I just love the book. So that's how many people would be in Fredericksburg after 20 years. It's kind of cool. It's almost double. Well, look at the percent, 2.9. It's actually a little higher. Could be a little. No, 1938. Not quite. Okay, so then what value does your function model give for the population of Fredericksburg in the year of 1980? Now, don't freak over this. It's simply P of t equals 19,360 e to the 0.029. Now, when was 1980 from 2000? 20 years ago, negative 20. See the difference? 2020 was 20 years forward from 2000 in the original problem, so it was t was positive 20. Here, because we're going backward to 1980, t is negative 20. Should be no big deal. In all honesty, it isn't at all. Don't get yourself all crazy confused over it, because it isn't. And you end up with 10,839 people. Now, there is another way to do this, actually, but I find this is the most straightforward way for what we're doing, so we'll go with this. Now, it says use technology to estimate the number of years it would take Fredericksburg to grow to 40,000 people, assuming the population trend continues. Now, you could do this. 40,000 is my final population. 19,360 was my initial population. E to the 0.029 t. But here's your problem. You have to solve for t. And we've not solved for t in terms of logarithms yet. So you could do this, but it's going to end up, I'm going to end up talking about stuff that we haven't even learned yet. The best way to do this is go to your calculator and punch in the formula 19,360 second ln, and that's 0.029 x. And then I go to Y2 and put in 40,000. Okay, make sure you change your window. Obviously, 40,000 is going to be a straight line. What I'm trying to get this to look like, here's 40,000. Okay, so this would be that 40,000 mark. And then the actual function itself, the 19,360e to the 0.029x is going to be a curve. Oops, I got to get my x's. It's going to end up kind of doing something like this. And then at that intersecting point is where the population and how many years is down here, will be covered for 40,000 people. Now my window, I had to make my window X, I made 50. And then, perfect. I wish I could show you this. I actually could probably on here, but again, I don't want to waste the time with it. Oh, you know what? On the next video, I'll show, I can flip to Desmos. I'm still getting used to this. But I give the exact curve as I showed you. Then just do second calc intersect. Spelling would help. Okay, that's a C. So second trace, I mean. Intersect is number 5. Enter, enter, enter. And in 25.023116 years, so in 25 years, so obviously don't look, yeah, my scale here, this should be funny. If this is 25, what should I go? 17, 9, and 1. Just go with it, please. But in 25 years, the population will be 40,000. It's kind of neat how it works. I think that's way easier than doing logarithms right now, to be honest. Okay? So that takes us to the end of our lesson. Now, I did a practice, a review, and a summary, and then what I did here is I put some practice problems. Okay, you've got this Fairview High School depositing money into an account, so there's your account. Kyle putting money in for his birthday. Dennis putting in money. There's a compounded continuously, so there's a PERT. Then predicting the population of Detroit. Sasha depositing money, and then Beijing. So I've got a few problems for you guys to try. We can go over these on Monday. Nothing to submit today. Hope you have a great weekend.